So organic synthesis. So first of all, we have elucidating organic molecules. Okay, let's take a look. You are expected to be able to identify organics functional group, their properties, how to test for their presence, and how they are made. So all these we have learned from the previous organic chapters. This is like putting everything together. Okay, so we start from functional groups. The table below summarizes the test to identify the presence of certain functional groups and the reactions to make them. Okay, so make sure you know what is functional group. Functional group is the structures in the molecules that involve in chemical reactions. So for example, alkene, the functional group is CC double bond because these involve in chemical reactions. Okay, now let's take a look. We look at the table here. It's actually a summary of everything. Okay, so we have alkane. So for alkane, we have two columns here. One column is the productions, the test, and then the other column is the productions. Okay, so we have the productions of alkane here. We can do hydrogenation of alkenes using hydrogen gas with platinum and nickel catalyst, and then you heat. So it's basically something like this: CC double bond plus hydrogen gas, and then the hydrogens go to each of the carbon with double bond, and then we get alkane. So the double bond just now becomes single bonds, and then after that we have the cracking of crude oil using heat and aluminum oxide catalyst. So cracking is to break down a long hydrocarbons into a short hydrocarbon. So alkane is produced. So this is one of the way to produce alkane. Okay, now alkene. So we have a test for alkene. Decolorizes bromine water. So that means you add bromine water to alkene, and then after that the bromine water will turn from brown to colorless. So this is the test. And then the productions of alkene, let's take a look. Eliminations of halogenoalkanes by heating it with NaOH in ethanol. Okay, so this one will take a quick revision. So you have halogenoalkane, which is like this. We have X here to represent the halogen. So when you use NaOH in ethanol, so what happened at the end is that we remove these two. Okay, so when they remove that two, you will get C double bond C plus HX. So this is eliminations reactions. Okay, so beside that, we have the second way for the productions of alkene. We have dehydrations of alcohol. Okay, dehydrations of alcohol. Let's take a quick look. So let's say this one, I put arrow. This one, I put arrow again. You have C, C, H, and OH. This is alcohol. And then after that, you use, let's say you are using aluminum oxide as your catalyst. So of course, if you are not using this, there are other options like concentrated sulfuric acid is fine also. So what happened is you are going to remove away the HOH, which is water, and then you will get CC double bond, the alkene, together with water. Okay, so this is dehydration or elimination of water. And the third way is written here, cracking of crude oil using heat and aluminum oxide catalyst. So again, cracking, same with this one, cracking of crude oil produce alkene and alkane. Okay, so that's why alkane can be the product. Alkene must be a product also. You know, for sure that will form alkene. If you still remember the equation that we discussed before, that will form alkene plus hydrogen gas or alkene plus alkane. So alkene must be there. Alkane depends. Okay, it is there or not as the product, depends on what kind of crude oil are we using. Okay, so then we look at the third one. Halogenoalkanes, we have primary halogenoalkane, secondary and tertiary. Halogenoalkane, we have 3 types. Okay, so of course, if you can't remember who is primary and who is secondary, so a quick revision. C with halogen. Okay, so if you have 1 alkyl group and 2 hydrogens, this is primary. Secondary is CX, 2 alkyl group, R prime and 1 hydrogen. So 2 alkyl group. And tertiary is 3 alkyl groups, R prime and R prime prime. So that is tertiary. Okay, so the test: form silver halides precipitate with dilute nitric acid, silver nitrate, and dilute ammonia solutions. Okay, so that means if you are using chloroalkane, then they will form silver chloride, where silver chloride is white color. If you are using bromoalkane, then they will form silver bromide, where silver bromide is cream color. If you are using iodoalkane, then they will form silver iodide, which is yellow color. And once they form the precipitate, you add dilute ammonia solution to check their solubility. Okay, so where AgCl will dissolve in dilute ammonia solution, but AgBr and Agi are not dissolved in dilute ammonia solution. And then you have to use concentrated ammonia solution, where AgCl will dissolve, AgBr will also dissolve, Agi will not dissolve. So this is also under revisions. Okay, we have learned this before. Okay, now let's see on the other side, the production of halogenoalkane. So we have free radical substitution of alkane using UV and a halogen. Okay, so a quick example. Let's say you have alkane, where everywhere here are hydrogens. Okay, then you add chlorine under UV light. So one of the chlorines will go and substitute the hydrogen. So let's say they substitute here, and then it becomes halogenoalkane or chloroalkane for our case here. Okay, then the second one, electrophilic addition of hydrogen's halide to alkene. Okay, so a quick look. This one is where we have the CC double bond plus HCl, for example, and then one H will come here, Cl will go here. So again, for this case, they form halogenoalkane. Okay, now the third one, nucleophilic substitutions are alcohols using hydrogen halide or PCl3 and heat, or PCl5 or SOCl3. Okay, so what happened here is no matter which one you are using, in general, the alcohol, which is like this, and at the end, okay, so no matter you are using HCl, PCl3 and PCl5 or SOCl3, at the end what happened is the OH is replaced by Cl. Cl will replace the OH, the rest remain, plus something else. Okay, so I just put it in general. Okay, now let's move on. So we have done this page. So on the next page, we have alcohol. So again, alcohol, we have primary, secondary, and tertiary. So primary alcohol, very similar to the primary halogenoalkane. So it is a carbon that linked to OH. If this carbon linked to one R, and then this is primary. Secondary is the carbon that linked to OH is linked to 2R. And tertiary, the carbon that linked to OH, so it linked to 3 alkyl groups. Then this is tertiary. Okay, now let's see the test. React with carboxylic acid and sulfuric acid to make ester. You know, alcohol plus carboxylic acid become ester. The sulfuric acid is the catalyst here, or the dehydrating agent at the same time. Okay, to make ester which have sweet, fruity smell. So remember that, alcohol plus carboxylic acid become ester. So primary alcohol gets oxidized to aldehyde, give positive tests with Phthalate and toluene solutions, and carboxylic acid. Carboxylic acid is formed, okay? So which means primary alcohol, you want to test its presence. So what you need to do is you oxidize it to aldehyde first. Okay, you oxidize it to aldehyde, and then you test with phthalate and toluene. Okay, so if it works, of course you have to remember the observation, where phthalate will change to break rates precipitate, and then toluene will change to silver mirror. If that happens, that means your alcohol is primary alcohols, and the aldehyde will get oxidized to carboxylic acid. Okay, so that is the test. If your alcohol is secondary alcohol, the way to test it is you oxidize the secondary alcohol to ketones, and then after that you test with 2,4-DNPH. 2,4-DNPH will show positive results. Okay, will show yellow, but toluene and phthalate, no observable change. Tertiary alcohol, we can only say that it doesn't oxidize. Okay, it doesn't oxidize to aldehyde to ketones. Okay, so we can't oxidize it. So we can't use the similar tests. These are the tests, and the productions of alcohol. So we have the first way, electrophilic additions of alkenes. Using hot steams, concentrated phosphoric acid act as a catalyst. So what they trying to talk about is this reaction. You have a CC double bond, then you react with H2O. So the H will go to one carbon, another one is OH. OH will go to another carbon. Like this. And the next one, oxidations of alkenes using cold dilute KMnO4. to form a diol. Okay, this one is like this. CC double bond. We have oxidizing agent plus H2O. Then they will form diol. So diol means OH on the 2 carbon, which is previously having a double bond. So that's the diol. So diol is after all alcohol as well, because there are OH group there. Okay, so alcohol. Now the next one. Nucleophilic substitution of halogenoalkanes using heat and NaOH aqueous. So example, that's a simple chemical equation. Okay, so you have halogenoalkane. I put X to represent the halogens. Then you have the, okay, straight away lah. Yeah, using NaOH aqueous. So not NaOH ethanol. NaOH ethanol you get alkene. NaOH aqueous you will get alcohol. Okay, so of course you have to do heating also. Then what happens is the X replaced by OH. Okay, so something like this, and then plus NaX. NaX, the sodium hydroxide becomes sodium X, sodium chloride, for example. Okay, now we look at the next one. So the next one is reductions of aldehyde and ketones using NaBH4 and lithium aluminum hydride. So aldehyde are reduced to primary alcohol and ketones to secondary alcohol. So this is the other way around compared to the oxidation that we discussed just now, where primary alcohol changed to aldehyde, secondary alcohol changed to ketone. That is oxidation. But now it's the other way around. Primary alcohol changed to aldehyde. Okay, so let's take a quick look on the simple equation. So if you have primary alcohol, okay, where it is going to be like this. So let's say this is primary alcohol. Okay, let's say I use R and H to represent primary alcohol. Primary alcohol. Okay, so when you do reductions, when you do reductions on this primary alcohol, so what happens is if you form R, C, double bond O, and then H. Okay, so plus, okay, first you can see from here, this hydrogen, okay, maybe I put arrow, this hydrogen disappear, this hydrogen also disappear, and then here become double bond. So 2 of this hydrogen will form water. We form water, dehydration, we form water. Okay, we form water, and then there is another hydrogen there supplied by the reducing agents, so they will form water also. Okay, so this is reduction of aldehyde to primary alcohol. Okay, so they will form water. And then next one, secondary alcohol. Let's compare. Okay, so this is where the idea is more or less the same. This hydrogen and these hydrogens are removed. So when they remove, they form ketone. And these 2 hydrogens, what happened to them? They form water. Okay, so that is reductions to form aldehyde and sorry, this is oxidation, sorry, the other way around. Okay, the other way around. No wonder feel like a bit weird. Okay, so it's the other way around. This is oxidation. Okay, reduction should be like this. Okay, so it starts from aldehyde. Okay, and then reduction happens here where you have hydrogens. So the hydrogen is added to the oxygens and then to this carbon. And then this is primary alcohol. Okay, then for ketone, ketone is initially like this. So you add hydrogens to the same positions. The oxygen become OH, and then sorry, here no hydrogen. Okay, the other hydrogen we add at the bottom. So then another hydrogen add at the bottom. So you can see aldehyde become primary alcohol and ketones become secondary alcohol. Okay, now we look at the next one. Reduction of carboxylic acid using NaBH4 or LiAlH4 or hydrogen's platinum catalyst and heat to a primary alcohol. Okay, let's take a quick look on the equation. So now you have carboxylic acid. Okay, so you add hydrogens and it will form primary alcohol. Okay, it will form primary alcohol. So R C H O H H. Okay, so what happens is you can easily see that the hydrogen is added to this carbon. Hydrogen come here and here. Okay, this oxygen is removed and then they will form H2O. They will form H2O. Okay, then next one we have the hydrolysis of ester using dilute acid or dilute alkaline. Okay, let's say example. You have ester RCOO R prime. So when you do hydrolysis, so we have two situations. H2O with H plus. This is called acidic hydrolysis. So remember you have to break the functional group at that particular point where I put in blue color. So that will form the original component, which is RCOOH, the carboxylic acid, and R prime OH, the primary alcohol. Okay, so of course if you are using H2O and alkaline, then you should expect the carboxylic acid is neutralized to salt. The alcohol is still there. Okay, so that is where they form alcohol. So there are so many ways to form alcohol, as you can see there. Okay, now let's move on. The next one is aldehyde. So aldehyde, the test, we can use silver mirror in Tollens reagents. Okay, so that means you add Tollens reagents to aldehyde. Tollens reagents will produce silver mirror. And you add sphaling solutions to aldehyde. Sphaling solution will form red precipitate. Okay, so you can also add 2,4-DNPH to aldehyde. That will form orange precipitate. Orange precipitate. Okay, so to produce aldehyde, we can oxidize, we go through oxidation of primary alcohol by slowly adding warm alcohol to acidified K2Cr2O7. This is the oxidizing agent, potassium dichromate 6 or potassium manganate 7. Okay, you can add the warm alcohol to these two, and then they will change to aldehyde, and you have to do distillation to get the aldehyde, or else it will continue the oxidation and become carboxylic acid. So we need to distill it. Okay, so the equation, this is the equation. So aldehyde, we oxidize it, so it will become, primary alcohol, we oxidize it, and then it become aldehyde. Okay, so what you can see is they are removing the hydrogen here and here, then they form water with the oxygen. Okay, now let's look at ketone, the next one. Ketones, the test is you add 2,4-DNPH, they will change to orange precipitate, and the production is oxidize the secondary alcohol by slowly adding warm alcohol to acidified K2Cr2O7, same with this one, or KMnO4, and then you do distillation. Okay, so the equation. So let's see the equation here. We are using secondary alcohol. So this is secondary alcohol. So you put oxidizing agent, and then they will change to ketone. This one become double bond O. Okay, so again you can see the hydrogen is removed from here and here, and then they form, they combine with the oxygens, then they form H2O. Okay, now next one, carboxylic acid. So the test for carboxylic acid, react with carbonates to form CO2 gas, which will turn lime water cloudy. So this is a test for carboxylic acid. And then the productions, oxidations are aldehyde and ketones. Oxidation of aldehyde is okay. Oxidation of ketone is a problem, it's a mistake. Okay, so as we know, primary alcohol can change to aldehyde. Aldehyde you oxidize to carboxylic acid. Secondary alcohol change to oxidize to ketone, and then after that end of story already. So should not have ketone here. Okay, then we just look at the equation. So we have aldehyde, you oxidize, and then it become C double bond O remain, this one become OH. Okay, so it happens to aldehyde, but not on ketone. So this ketone I cut away. Okay, now next one. Hydrolysis of nitrile with dilute acid or dilute alkaline, followed by acidification. Okay, let's see the equation. So we have nitrile. Nitrile is R, C, triple bond, N. This is nitrile. So this nitrile, you react with two situations, either alkaline or acid. So we have H2O and H plus. then what happened is they will change to R, C, OOH, and NH4 plus. So something like this will happen. They will change to carboxylic acid and conjugate acid. Okay, so the ammonia after receiving proton, we call it conjugate acid. So if you are using alkaline, H2O and alkaline, for example this one, so that will form RCOO and A. So as the carboxylic acid is neutralized by the alkaline, and then the other one is ammonia. So they will form alkaline, and this is called conjugate base. So conjugate base is the carboxylic acid after losing the proton, then it becomes conjugate base. Conjugate base and alkaline. This one conjugate acid and acid. So let's move on. The third way, hydrolysis of ester with dilute acid or dilute alkaline, followed by acidification. So the hydrolysis of ester we discussed already, as you can see up here. So this is hydrolysis of ester. So you can form carboxylic acid, or you can form salt or carboxylic acid if you are using alkaline. Okay, so use alkaline, then you will get this. So if you get this, then you have to add acid. You add acid, then that will reform the carboxylic acid. That's why they say followed by acidification. So you add acid, then the salt will change back to carboxylic acid. Likewise over here, dilute acid followed by acidification. Let's look at it again. You use alkaline hydrolysis, you get salt of the carboxylate. So then you add acid to it. You add acid, that means you add acid to this thing, and then this thing will become RCOOH. So we get carboxylic acid after doing that. Okay, now we move on. Ester. So the test for ester is we just smell it. Have sweet, fruity smells. And then it's ester. The productions, condensation reactions of alcohol and carboxylic acid. Or you can call it esterifications. With hot concentrated H2SO4 as catalyst. So this one, take a quick revision on the equation. So we have carboxylic acid, RCOOH. Then we have alcohol. I put alcohol in this order. Okay, then they can take away the OH and the H. And then they form ester. RCOOR prime plus H2O. And they form ester. Okay, now let's move on. Amines. Okay, so amine, what happened is, amine is alkaline. So it will turn universal indicator blue or purple. Turns it to blue or purple, showing that it is alkaline. Okay, so productions, nucleophilic substitution of halogenoalkanes when heated under pressure with NH3 in ethanol. Okay, let's look at the equation. So Rx plus ammonia, so it becomes R NH2 plus HX. And finally nitrile, no test, but how to produce. Nucleophilic substitution of halogenoalkane with KCN ethanol and heat. Okay, equation Rx plus KCN become RCN plus KX.